Question number 9. The line y equal to mx plus 4, this line, meets the line x equal to 2. X equal to 2 is this line, x equal to 2, and x equal to minus 1. This is my x equal to minus 1 at the point P and Q. So this is the line we are talking about. Okay, the point R is such that QR is parallel to y-axis. Okay, so this is parallel to that y-axis. That's telling me that this is perpendicular on the x-axis, this two. Okay, and the gradient RP, this is gradient RP equal to 1. That's given information. The point P has coordinates 2, 10. That find the value of M. All right, so we are going to deal with that. This line has point P which has coordinates 2 and 10. So y equal to mx plus 4 passing through, you don't need to write down that, I'm just showing you this. Okay, P 210. So what I'm going to do, I'm going to replace the value of y and x with 10 and 2. So in the place of y, I'm going to put 10, and m, this is 2 plus 4. So 10 minus 4 is 6 divided by 2. M is going to be 3. Okay, that's my answer for M. Okay, find the coordinates of Q. I need to find out coordinates of Q. Now, this is x equal to minus 1. So no matter what, it's a vertical line parallel to y-axis. Every x coordinates of this line is going to be minus 1. Okay, so this is this line. Y equal to m, I got 3, and x I got minus 1 here. Okay, plus 4. So this is minus 3 plus 4 equal to 1. Okay, so Q, coordinates of Q is going to be minus 1, 1. So I'm going to write down this over here. Now, question number 3 says that find the coordinates of R. So coordinates of R. Again, as before, I know that coordinates of x coordinates of R is minus 1. I don't know the coordinates of B, so y, so let it be B. Okay, but one thing I know, the gradient of this given 1. So what I'm gonna do, gradient of PR, that's given 1. Okay, this is given information. Okay, given. Now, gradient is the difference in y-axis divided by difference in x-axis. So P, I have 210, and R, I have minus 1b. So when I'm writing this, let's see if you can see everything here or not. So 10 minus b divided by 2 minus 1. Okay, equal to 1 according to the question, right? So that's going to be 10 minus b, and this is going to be minus plus 1. So 2 plus 1 is 3. 3 times 1 is 3. So b, if I take b this side and bring 3 this side, b is going to be 7. Okay, so I have the coordinates of R minus 1, 7. So let's rewrite this. Minus 1, 7. That's the coordinates of R. Okay, so that's done. Now it says find the equation of the line through P perpendicular to PQ. So this is my PQ and perpendicular to this. I just draw this one. Okay, it's going to be perpendicular to that one, and let it be a gradient of this line L equals to, remember what was the gradient of this particular line? It was 3. So that's going to be minus 1 by 3. Why? Gradient 1 times gradient 2 equal to minus 1 if L1 is perpendicular to L2. I hope you remember that. So that's gradient of this. Okay, what I need to do, I need to find out the equation of the line through P. So through P, coordinates of P are 2 and 10, and that gradient L is minus 1 by 3. So I can find out the equation really easy using that formula. Let me write down this formula over here. Y minus y1 equal to m x minus x1. Okay, here is the gradient and this is the coordinates. So y minus y1 is 10 equal to minus 1 by 3 x minus 2. In the form of ax plus by equal to c, so bring this 3 over here. 3y minus 30, and don't forget this negative sign. If I take the bracket up, this is going to be minus x, 3 on that side, minus minus plus 2. That's that. Bring everything over here, and then I'll be having x plus 3y, taking that to that side, it's going to be 32. Okay, so a, b, c are integers. You can say that a equal to 1, b equal to 3, c equal to 32. Okay, you don't need to write down that because question is asking to write it like this way. It's done. Okay, now next one. Find the coordinates of the midpoint M of the line PQ. What are the coordinates of P and Q? P is 210 and Q, coordinates of Q are minus 1, 1. Minus 1, 1. Therefore, midpoint, let it present by M. I don't have any M, so capital M. And then we know that difference in x-axis divided by 2. So 2 minus 1 divided by 2 and 10. Actually add them. Okay, not difference, the sum of that, average of that. So 10 plus 1 divided by 2. So this coordinates would be, coordinates of midpoint of PQ would be 1 by 2, and that's 11. So it's 11 by 2. Keep it like that. Okay, you can write down 0.5 and 5.5. Okay, no need, but just in case. Okay, that. Now find the area of the triangle QRM. So QR and M. All right, so let's draw that for a second. There are so many different ways you can do that. Let's say this is my M over here, and that's 0.5 and 5.5, and Q is down below here. Q is minus 1, 1, and R minus 1 and 7. This is vertical line. I hope you can see this. Let me draw it with different color. This one, this perpendicular line is difference of x-axis, that's 0.5 and minus 1. From minus 1 to that, so minus 1 to minus 0.5, that's supposed to be 1.5. Okay, so that's going to be 1.5. Now what would be the area? Required area would be half. Base is difference in y-axis, that's 7 minus 1. Let me write down that 7 minus 1 and multiply by that's 1.5 means 15 divided by 10. That's actually, if I cross it by 5, 3 by 2. So 3 by 2. So that's gonna be half times 6 times 3 by 2. So that's cross out to 3. So 9 by 2, or we can write down 4.5 square unit. Okay, you could do this way. I'm not going to do the next one, but I'll just show you how you can get that one with the modulus 1. Go anti-clockwise. So minus 1, 1, 0.5, 5.5, then minus 1, 7, and this one we repeat that. And what you need to do, you need to multiply this with this, this with this, this with this, and then minus all the summation of this product, this, you should get the same answer. I'm not going to do that. I'll just let you do this. Okay. If you cannot do it, leave it in the comment box. I'll show you in another video. Okay. Let's do question number 10. Okay. The function f defined by, oh, this is modulus 1. Okay. Absolute value 1. Sine x. Okay. For x to be 0 to 360. I have 0 to 360. They were very nice to draw that. Okay. So we know that amplitude is 1. Amplitude is 1. So highest is gonna go, let's say, I'll just do this one. Okay, I don't need to do that. It's just a sketch, but we want to make it look good. Okay, so that's gonna be 1 and that's gonna be -1. And over here I can draw a dotted line real quick. Okay, don't spend too much time on this if you don't have to. If you should know everything about this. Okay, if you don't know, then take your time. Okay, all right. So sine graph is pretty simple. It's gonna go from here, then here, comes over here, comes over here, comes over here. So usually the graph's supposed to be looking something like that. I'll stop right over here. Okay, it's modulus. Okay, modulus means it shouldn't have any negative sign. Okay, but the negative value. I'll just put that dotted line over here to show that if we didn't have this modulus sign, it should be looking like that. But since it's modulus, the way it's given, this part will be reflected on x-axis. So the graph originally, it's gonna be changed and be like this. Okay, I'll just use the green color to show you how this graph's supposed to be looking at. It's supposed to be like that, and that's y equal to absolute value of sine x. Done. Okay, now next one. The functions g and hg, this is composite function, are defined for x is greater than or equal to 1. That's the domain given. G of x given ln 4x minus 3, and composite function g hg of x is x. Okay, this one is telling me something. Okay, x is always equal to function inverse function of x, or you can write down inverse and then function of x. Okay, so that's how it can be written as. Okay, so when it's like this, hgx equal to x, h of gx like that, and putting in this format, say that g of x over here, and we're comparing that, so hx looks like inverse of gx. Okay, so I have to take gx over here. Gx is ln 4x minus 3, taking this it's to be y, so ln 4x minus 3, making x is the subject. So here is log base e, so 4x minus 3 is nothing but e to the power y. Okay, now making x is the subject, so x is going to be e to the power y plus 3 divided by 4. Therefore, remember g of x, so g inverse x would be, we just replace the value of y by x plus 3 by 4. Therefore, we can show that since g inverse x equals to hx, therefore hx is nothing but this value over here, e to the power x plus 3 divided by 4. It says show, so write down shown. Okay, so that's it. Let's do the next one. The diagram shows the graph of g of x. This is g of x. So this coordinate is gonna be 1, 0. Okay, I can't tell you the first point over here. Okay, because the domain of the function, any function, this g of x is gonna be range of that. So that's gonna be, and this one is gonna be 0. Okay, its range is gonna be its domain is gonna be its range. Okay, and this is going to be reflected on it's a sketch, so just to have an idea, they want to see if you have the clear idea on this one or not. Y equal to x line. Okay, any function and its inverse should be reflected on this line. Okay, so in that format I can go it like this. Okay, go in like this and write down that what it says, graph of that inverse function, and h are inverse function. See that g and h of inverse function. Sketch on the same diagram the graph y equal to h. So y equal to h of x. As in the previous question we have seen that h of x is nothing but, I'm going to write down this, h of x is nothing but g inverse of x. Okay, I said that, but I didn't write it down. It works over here. Okay, you can take one more point to do that. I don't think you need more. Okay, because it's only 2 points. You got that. Okay, if you really want to use this one, so what my suggestion would be, see that g of x, you have something over here. You can take some values, okay, some values to get another value of y. Okay, I don't know, probably you can take a 3 by 4. That's no, I want 1. Okay, so 4. If you take x equal to 1, okay, x equal to 1, then this ln x, that means y gonna be 0. I think it's this point over here. Okay, so what is the another value you can take? Okay, you can take the value of e, and you'll find out that it's gonna be somewhere over here. Okay, now come to this one, state the domain of h. Okay, so domain of h is the range of function of x. Now g of x. Okay, now g of x, that's actually the domain is x is greater than or equal to 1. So here whenever it's 1, we see that it's 0. So this is the range of g of x. It's going to be domain of that. So it's going to be domain of that x is greater than or equal to 0. That's it. 1 marks question, nothing more. Okay, state the range of h. Range of h. Whenever we are trying to find out range of x, that's the domain of that. So we can write down y is greater than or equal to 1. Okay, what that's going to give us, when it's 0, we're going to go to the infinity. Okay, it's a start from 0 to take us really close or to the infinity. And this one, when you are taking a, you don't need to do this one, but this answer will do the work. Okay, so that's done. We are going to the next question now. Okay, question number 11. It has this right triangular base pyramid, not triangular base, a square base pyramid. The diagram shows a cuboid. This is a cuboid, not a cube. So height h, this height is h of this cuboid. Unit inside the right pyramid OPQRS of height 8 centimeter. Okay, and sorry, 8 units, and with square base. So this square base, this is 4, this is 4. The base of the cuboid sits on a square base PQRS. They're sitting on that of the pyramid. The point A, B, C, D are corners of the cuboid and lie on the edge OP, this one, OP, OS, this, respectively. The pyramid, the pyramids, this and this are similar, this and this are similar. Okay, so since this is in a square, we know this part is a square, they are equal. Okay, this is not equal. Now find an expression for AD. So this is AD, okay, in terms of h, and hence show that the volume is this. Okay, so what are you gonna do? We're gonna deal with this part over here. This AD is proportional to that. Why we want to do that? See this, if we join this line over here, okay, this one over here, this is similar. So this side and this side proportional to, I take that one, h over 8. Let me write down whatever I'm talking about. AD over PS, that's 4. Now AD was the cuboid's height over here. So yeah, length over here. So cuboid's height is h, and the whole thing is going to be 8. But look at this. This h is fine, okay. But we are talking about this two triangles, this two pyramid, one on the top, another one. So actually I need this one. It's 8 minus h. I'm not dealing with that. Okay, this is cuboid and this is the pyramid. I need to compare this small pyramid with this big pyramid. So this is going to be 8 minus h. Okay, so AD is going to be, if I cross this one out too, it's half 8 minus h. Keep that one in your mind. Okay, I hope you can see that this small pyramid is similar to the bigger pyramid. Okay, so don't compare cuboid with the pyramid. Compare small pyramid with a bigger pyramid. Okay, then their corresponding sides and lengths and heights are proportional. Now volume of the cuboid. Okay, we need to find out the volume of the cuboid. Now we know that AD and DC are equal. So AD, I got that. Let's put that AD square times, I need this one, and that's our H. And AD is nothing but half 8 minus H, that whole thing squared times H. If I take the bracket off, 1 by 4, and that's gonna be 64 minus 16H plus H squared times H. And if we take the bracket off, it's going to be, look at this cross out, and I'm gonna end up with 16H minus that gonna be 4, this H and H is H squared, plus this is gonna be H cubed divided by 4. So if I rewrite that, H cubed by 4 minus 4H squared plus 16H, and that's nothing but this one over here. So we just write down shown. Okay, that's done. Now, given that H can vary, okay, find the values of H for which V is maximum. What that actually means is, given that H can vary, right? So dV dH is 0 at maximum or minimum extreme point. Differentiate of volume with the height is 0. So what was the volume again? Volume was this. Okay, let me write down that. Volume was H cubed by 4, H cubed by 4 minus 4H square, 4H square plus I think 16H. Yeah, 16H. So when we differentiate that with respect to H, I have 3 by 4 H square, then I have minus 8H plus 16 equal to 0. Now if I take 4 common, then I'm gonna have 3H square here, that's gonna be 32H, and 4 times 16 is 64, 0 times 4, that gives me 0. Now you can do the middle term break, or I'll just, to save some time, I'm gonna use that equation, solving equation with the calculator. My power degree is 2, A is 3 minus 32, 64. I got one of the H equal to 18, and another one is 8 by 3. Now I have to see if both of them are correct or not. Be careful, okay? H, if this H equals to 8, that actually equals to the height of the whole pyramid. So H over here cannot be equal to 8. Therefore, H equal to only this part, 8 by 3. That's actually 2.67. Okay, so that's my final answer. Okay, I hope you understand. If you don't, please check that video again, rewind it and see that. We're gonna go to the next one. Okay, question number 12. Show that x equal to minus 2 is the root of the polynomial this. Let this polynomial be 15x cubed plus 26x squared minus 11x minus 6. So when we replace the value of x by minus 2, all the x replaced by minus 2 here, cubed plus 26 minus 2 squared minus 11 minus 2 minus 6. So that's going to be minus 8. So it's going to be 8 minus 8 times 15. So I got minus 120 plus minus 2 squared is 4. 4 times 26, that's give me 104 minus minus plus 22 minus 6. That's gonna give me minus 120 plus 104 plus 22 minus 6. That's gonna give me 0. Therefore, x plus 2 is a factor, and x equal to minus 2 is a root of this function of x. Okay, so that's that, and it's shown. Okay, shown. I write a lot of lines, steps. Therefore, I need more space. I just did it this way. I hope it doesn't bother you. Okay, you can see that. Find the remainder when this is divided by x minus 3. Now, again, I'm going to replace x by 3. So it's 15, 3 cubed plus 26, 3 square minus 11 times 3 minus 6. That's going to give me 27. See, 3 cubed is 27. 27 times 15, I got 405. Then what happened? Next part is remainder. Yeah, 26 times 9, I got 234 minus 33 minus 6. So what do I got? 405 plus 234 minus 33 minus 6. I got 600. Therefore, remainder equal to 600 when it is divided by x minus 3. Done. Okay. Find the value of p and q such that this cubic expression is a factor of this degree 4 expression. What that actually means, that if we have some values like that, ax plus b, I love to do it this way. It's pretty interesting. 15x cubed plus 26x squared minus 11x minus 6, that is identical to this linear expression with this cubic expression whenever we multiply that x to the power 4. So it becomes 15x to the power 4 plus px to the power cube minus 37x squared plus qx plus 6. Okay, so we're going to multiply this one out. So 15 ax to the power 4, then plus 26 ax cubed minus 11ax squared minus 6ax. I multiply each and every term by ax. Now it's time for b. Plus 15bx cubed, now this with this, plus 26bx squared, then minus 11bx minus 6b. We're going to come to that later on. Okay, so later on to that. X to the power 4, I don't have any terms with x to the power 4. So 15ax to the power 4. I have x to the power 3 here, x to the power 3 over here. If I take x to the power 3 common, then I have 26a plus 15b right here, and x squared. So if I take plus x squared common and write this one, 26b minus 11a. So this gone, and x is over here. I have to take that common. So 6a plus 11b, this is x. And then I have minus 6b is identical to whatever that comes. Now this first term over here, 15x to the power 4 and 15 that. If we are equating the coefficient of x to the power 4, that gives me that. So a equal to 1. I got that. 1 a is, I got it. So a and b, I'm going to compare this a and b over here with x's power, that's q. This is x squared, a and b. Yeah, I'm going to go for that. The reason is over here I have a and b. I just need to get this, and I have q as well. If I'm checking that, I'm going to do this one. 26b minus 11a equal to minus 37. And a, I know the value of a is 1. So 26b minus 11 times 1 is 11 equal to minus 37. So 26b, if I taking to that side, it's going to be minus 26. You can see that this one go there, it's going to be 11 minus 37. That's minus 26. So b equal to minus 1. Now I'm ready to take this one. Okay, this thing. Okay, where is that? This thing. Okay, you could have taken this one, 6b with 6. That's gonna give you b equal to minus 1. But that's okay. As soon as since I have done that, minus 6a plus 11b, that equals to q. Okay, so I know one a is 1, so minus, that's 6, and that's minus 11, that's minus 11 equal to q. So 6 minus 11 is minus 5, that's q equal to 5. Now I need P. Okay, I think I need P. P is, where's P? P is with cubed, see that? P x is cubed. So I have to find out x is cubed over here. Okay, so 26, A is 1, so I don't need to write down, and B is minus 15, so it's minus 15 equal to P. So P equal to 11. Okay, so I got this answer now. P equal to 11, Q equal to 5. That's it. Probably it's a little complicated, but this is easier if you can multiply and compare the coefficient. I think that should do it. Okay, if you don't understand that, please rewind the video and watch it. And if still you have some problems, write down in the comment box. I'll get back to you. Okay, thank you. Have a good day.